Welcome to an overview of MPT-IRIS's suite of innovative ERT IP instruments. MPT-IRIS Inc. is a manufacturer of high-quality, low-noise, and robust electrical resistivity tomography and induced polarization instruments, in geophysics commonly referred to ERT or IP instruments. We'll be covering each instrument, their main differences, their application suitability, and their main specifications. Our instrument suite contains the DAS-1, DAS-M, and multi-source systems. Their suitability for specific ERT IP applications distinguishes them. The DAS-1 is a robust, reliable, and worldwide established long-term remote monitoring system, also used for large-scale 3D, standard long 2D, borehole, and marine surveys. Our newest ERT IP system, the DAS-M, is reimagining the standard 2D and 3D surveys with its modular, semi-distributed design and multi-source/multi-line capability. The standalone multi-source is designed for exploration surveys to around 1 kilometer depth, depending on subsurface conditions, due to its patented multi-source capability. This distributed system can handle the toughest environments. This is a comparison table of key specifications for each system. The DAS-1 can handle 64 electrodes with its built-in multiplexer. It can be expanded by 64 electrodes at a time by adding a multiplexer and cables. It has 8 highly isolated receiver channels, each with a 24-bit analog-to-digital converter. The DAS-M can handle 16 electrodes and can be expanded by 16 electrodes at a time by adding a multiplexer and a cable. It has 4 highly isolated receiver channels, each with a 32-bit analog-to-digital converter. Each multi-source unit handles 3 electrodes, has 1 transmitter, and 2 receiver channels. Its overall configuration is determined by the number of multi-source units participating in the survey. Both the DAS-M and the multi-source systems feature the multi-source capability, have built-in GPS, and are radio controlled by a field computer. The DAS-1 system is a fully autonomous multi-channel ERT/IP monitoring system. It shines in frequent long-term monitoring surface or borehole applications. It is also well suited for large-scale 3D, long 2D, or marine surveys. It has 8 independent receiver channels, each with a 24-bit analog-to-digital converter, and it contains a fully independent high-isolation multiplexer, capable of switching 64 inputs to make 4-point measurements according to a customizable software schedule. All data modes and system functions can be operated locally, remotely under PC control, or autonomously. The time domain IP data collection can be performed at a base frequency of 1/64 Hz up to 13.5 Hz with up to 35 user assignable windows. It can also collect frequency domain IP data at base frequencies of 1/64 Hz to 5 Hz, acquiring phase and amplitude. As a third mode, it can make self-potential measurements at 1 or more receiver pairs. The DAS-1 can be expanded by 64 electrodes at a time using dedicated high-isolation multiplexers, making high electrode count possible for large-scale 3D surveys. Up to 255 multiplexers, or 16,384 electrodes, can be used. The main specification of the DAS-1 are shown on this slide. Please pause the video to review in more detail. Our newest creation, the DAS-M, is reimagining how ERT and IP surveys are conducted in the field. This advanced and intelligent acquisition system has a modular design that lets you customize the size of your system in increments of 16 electrodes. It features our patented multi-source technology coupled with 16 electrode cables, 4 isolated receiver channels, each with a 32-bit analog-to-digital converter, full waveform recording, radio communication, GPS timing and positioning, flexible spectral IP, and a modular design with expansion in mind. The multi-source technology allows for simultaneous operation of multiple transmitters and receivers at once for increased signal levels and control. The basic DAS-M system uses 1 main transceiver unit, 1 multiplexer unit, and 1 16 takeout cable with electrodes, plus a computer remotely controlling the whole system through a USB radio interface. The system is ideal for 2D applications of electrode multiples of 16, including roll-along applications. The DAS-M uses isolated lines for transmitting and receiving, which decrease the inductive and capacitive coupling in cables and multiplexers, and thus improves the quality of spectral IP data. The DAS-M also allows you to collect data across multiple lines that are not physically connected through its wireless radio connections and tight GPS synchronization. Independent lines can operate in urban areas, along and across roads, in medians, or around buildings without running cables across the roadways or obstacles. As added benefits for this portable system, it can also collect multi-source data with as many transmitters as DAS-M main units are present in the field setup. A more typical configuration would contain 2 main DAS-M transceiver units, 4 multiplexers, and 4 or 5 cables. This gives flexibility to either have one long 80 electrode 2D line or 2 separate lines of 32 electrodes each, as shown on this slide. Even more lines will further enhance the capability to resolve the 3D resistivity structure of the subsurface. With 2 or more DAS-M main units, data can be collected on as many lines, e.g. measuring between the red TX line 2 dipole and the green line 1 RX dipole, as shown on this slide. With multiple main units on multiple lines, the system can also collect multi-source data where multiple DAS-M units transmit simultaneously, e.g. transmitting on the red TX line 1 and TX line 2 simultaneously and receiving on the green RX dipole, or any other receiver dipole on either line. Using multiple sources simultaneously can enhance both the signal levels and the resolution of deeper structures. Shown here are the main specifications for the DAS-M and MUX-M. Please pause the video to review in further detail. The next generation of ERT system got its name, multi-source, from the unique ability to transmit from multiple transceiver units simultaneously. Using this feature, the system can achieve signal levels and depths of penetration almost comparable with systems that depend on high-power, motor-driven generators, and can be used to optimize the resolution of deep targets down to approximately 1 kilometer, depending on the subsurface conditions. The multi-source system consists of 2 to 255 separate transceivers that don't need to be physically connected. Each transceiver has 2 receiver channels and its own 350-watt transmitter powered by an internal 240-watt replaceable battery. It can also run on an external 12-volt battery. Each system has a GPS module for location and timing, as well as a wireless module for communication, as the individual systems are not physically connected by cables. Each electrode is connected by a single 1-conductor wire, eliminating the need for multi-conductor cables and cable management constraints on your layouts. The figure on the top right illustrates an example of what is possible with the multi-source system. It shows the survey layout across a harsh, mountainous area with over 500 meters of elevation change. The electrode locations are shown as black dots. The colorful dots represent the IP data measured with 25-meter and 50-meter multi-source dipoles and simultaneously transmitting on up to 4 systems to increase the depth of penetration. The multi-source data were complemented by acquiring equatorial dipoles across adjacent lines to add more 3D information. Our research has shown that manipulating the pattern of current flow from multiple simultaneous transceivers allows manipulation of the sensitivity patterns for subsurface targets, improving both resolution and depth of penetration. Trials to date of this cutting-edge technology have shown substantial improvements over traditional approaches. The theoretical model simulates dipole-dipole measurements over a 10 ohm-meter resistive body in a 2 ohm-meter background and multi-source measurements using 200-meter electrode spacings. The comparison shows that the multi-source inversion was able to resolve the resistive body around 300 meters deep with much higher resolution. As you can see in the sensitivity model on the bottom right, the receiver sensitivity/signal for the 5 simultaneous transmitter is roughly 5 times greater at depth compared to a normal dipole-dipole pair. Our research has also shown that manipulating the pattern of current flow through polarity changes of the multiple simultaneous transmitters allows for the sensitivity/signal to be customized for subsurface targets, improving both the resolution and depth of penetration in the area of interest. Once again, the main specifications of the multi-source system are included on this slide. Please pause the video to study them in more detail. That's all for now. Be sure to check out our other MPT-IRIS videos, and as always, thanks for watching.